data below my given data, right? Because again, remember the number less than that value. So the value is not at the 4 position. This is the number of data have to be below X. What is X? Well, looking at this thing here, there are 4 data below X. So the 5th position. The 5th position is the 20th percentile. Right? So looking at this thing here, which is again, that's what we need to do, which is again, the 23 years old is the 20th percentile. Okay? Again, the 3 steps I give you right here is we want to find how many value below. That's the number of data below the X. Right? So again, the corresponding age that we represent the 20 percentile is above that number, right? So if you calculate and you have 14, then again, the 15th position, right? The 15th position is the percentile position, is the data position, okay? So again, this thing here is just the reversal. Right here, we divide by n. Again, on the bottom here, we multiply, right? Just the opposite operation in terms of that. So again, the first thing is we need to find the percentile, divide 100, multiply to n, and then count how many data that you have, which is again, we have one more, the one more data, which is the item we have, right? Again, if you in doubt, think about this thing here, or if you in doubt, take a look at this. Do you agree that 23 is here, which is there are 4 data below 23. So if you were to do this thing here, you say, well, 4 divided by 20. What is 4 divided by n? Remember, 4 is the number of data less than 23, which is 4 divided by 20. Do you agree that is 1/5? Again, 1/5. If you take 1/5, that is 0.2, which is 0.2 times 100. That is your 20th percentile. Right? So again, it's just the whole, you know, if you good with algebra, you can see that we just do the reversal, right? We just convert backward. Okay? So let's take a look at another one here. Let's take a look at another one, and then I will see if you guys have questions with this item here, which is, for instance, same data we have before. It's just that now they ask you what is the age corresponding to the 75 percentile, right? The 75 percentile, which is, again, looking at this thing here, what do we need to do? Well, the first thing we need to do is we need to take the 75 and divide it by 100, right? So again, 75 divided by 100 will give you 0.75. And then you take this 0.75, you multiply to the total, which is, in this case, our total is 20. So again, 0.75 multiplied by 20, you will see that 15. So what is 15? Meaning, again, there are 15 individual data below my X. But so my X got to be at the 16th position, right? If we're looking for a position, it's going to be at the 16th position, which is, again, 15 data will be below the X value. Therefore, again, you count 15 data, which is, again, we count from up here all the way to 15. So number 37, or in terms of this thing here, the 16th position, right, will be my 75th percentile, okay? So again, that's the idea here is, again, just the reversal of the percentile rank, okay? So question with this thing here, any question in terms of how to find the percentile rank or how to find the corresponding age correlate to our percentile rank? All right. So that is basically it for 11.5, ladies and gentlemen. If you read a book or if you look at the book, there is a quartile. We won't do quartile in this class. When you get to statistics, we would do quartile, which is, again, instead of split into 100, which is the percentile, which is 100 slot, quartile, they just split into 4 slots, right? The 25%, the 50%, the 75%, and the 100%. So again, we will do, whoever go to statistic 203, you will do quartile up there. But for now, for us, we only do percentile. Okay. So let's take a look at the, probably the I don't know, it's weird. It's like it's the easiest, but the hardest at the same time. So 11.6, this is basically everything about chapter 11 is here, ladies and gentlemen. I think this is basically the backbone of statistics. Statistics will derive from this 11.6. Okay, so let's take up 11.6, which is 11.6 is a normal distribution. So one thing about a normal distribution is this, which is a symmetric, it's a continuous symmetric bell-shaped curve, right? So what does it mean is basically ideally, right? You know, if you collect data, it's going to be very hard, right? If you collect data, it will be very hard. But ideally, this is what we want. For your data to be normally distributed, is basically tell you this is you have 50% of the data above the mean, and you have 50% of the data below the mean. Okay, so in order to be normally distributed, meaning the mean is at the center. The mean is at the center, and then we will always have 50% of the population will be better than the mean, and there will be 50% of the population will be not as good as the mean. Okay, they are symmetric on both sides. So one thing about this thing here, to think about this thing here is, if you look at this thing here, it basically tells you that if we collect a lot of data, then eventually they will become normally distributed, meaning they become symmetric like this. So just think in terms of this thing here. If you flip the coin, right? If you flip the coin and you say, well, if you flip the coin, we have 50% head, 50% tail. So if I were to flip the coin 10 times, does it guarantee I have 5 head and 5 tail? Not quite, right? Not quite. Might be 3, 7, right? 3 head, 7 tail. If I flip 100 times, then I might have 60, 40, right? If I flip 1,000 times, maybe I have 550, 450. Meaning, as you can see, if I flip eventually, if I flip a lot of time, eventually it will come to that 50-50, right? If I flip 1,000,000 times, then again, it's going to be 500,000 head, 500,000 tail, right? So basically, ideally, if we have enough data, they will be 50-50 in that sense, okay? So this is some property of normally distributed distribution, right? So again, the value in the middle is your mean, right? The mean is right smack in the middle of your bell-shaped curve right here, right in the center. That's your mean, right? They are symmetric, which is 50% less and 50% greater than the mean. The area under the curve, which is the probability, later you will see, or this item here, because it's 50% less and 50% more, meaning the area under the curve will be equal to 1, okay? Which is the percentage of data. That's what we will do later, as we find the percentage of data, which is, again, this is what we have here in the sense of this item here, okay? So looking at this thing here, which is, again, take a look at this, let's say that they give you this thing. You probably won't have a lot of this normally distribution table that they give you the percentage. But again, let's say that they ask you this question here. The graph below shows a normal distributed of the height of the woman in the United States. The number on the horizontal axis are the height in inch, and some area are level for reference, right? So let's take a look at this thing here, which is, again, we have the height on the bottom here, and we have the area, which is the area is basically the percentage, right? If we move this decimal 2 places, this is 30.3%. This thing will be 3.4%. This decimal convert to percentage, you multiply by 100, right? So let's take a look at the question. This